Hi, this is Justin Aquilante, ESA Sales Director, here today with Dr. Matt Rayford, Technical Manager, Consortium for Battery Innovation. Matt, welcome.
Thanks, Justin. This is so great to speak to you guys about lead batteries.
Matt, can you tell us about the work of CBI in relation to energy storage?
Yeah, that's a good question. Well, first of all, CBI is a global nonprofit research organization for lead batteries in all applications. So we have research projects and demonstrations underway across many different applications. These include automotive, motive power, and energy storage. In terms of energy storage, a lot of our work is on the fundamental side and the deployment side. So in terms of fundamentals, we have projects with universities and national laboratories looking at materials going into lead batteries. And then on the deployment side, we have key partnerships with the United States military, as well as utilities, getting lead battery energy storage systems developed and constructed for various different applications in the utility services space. Furthermore, we have many different tools such as Battery Match, as well as an interactive map communicating the many different demonstrations and deployments for lead batteries and energy storage. And those can be found at on our website.
Matt, what research is currently underway at CBI to advance lead battery performance for energy storage?
Yeah, there's a lot going on, Justin. So at Argonne National Laboratory, there's a consortium consisting of American battery manufacturers and suppliers looking at the fundamental processes that govern cycle life for lead batteries and energy storage applications. That's been going on for several years now. And there's been a lot of key findings in terms of how best to treat lead battery electrodes and how to form them better. CBI has projects with the University of Warwick looking at smart charging algorithms and machine learning with lead batteries to maximize their lifetime and to make their use more efficient for a broad number of applications in the energy storage space. We also have an innovative project at INMA in Spain. They're doing neutron diffraction of lead battery electrodes under different energy storage testing protocols to study how lead batteries change over time, to better understand what causes failure, and to hopefully improve lifetime with some better understanding of these processes. Besides that, we have further research projects across America, ones with Electric Applications Incorporated, looking at a unique way of controlling overcharge of lead batteries to maximize lifetime in energy storage applications. And in Indiana, with the Hammond Group, we're looking at special additives into the negative of lead batteries to maximize lifetime, as well as other key performance metrics for batteries and energy storage applications.
Matt, what are the benefits of using lead batteries for energy storage applications?
Yeah, there's many benefits to using lead batteries in energy storage applications, Justin. They're safe, they're reliable, they're cost effective, and they're very robust across many different environments and climates. So in terms of safety, lead batteries, the electrolyte is water-based. Furthermore, the construction materials, the plastics used for the battery casings are well developed, and they're UL V0 compliant, which makes them highly flame retardant. This combination of water-based electrolyte and these kind of construction materials make them one of the safest types of energy storage to deploy, really period, whether it's in the bottom of a building or out in a field. The ability of lead batteries to be safe in terms of thermal runaway is much better versus other alternative technologies. In terms of reliability, there's long history of lead batteries in stationary applications. So in terms of how best to treat them and understanding their life cycle across different usages, there's massive amounts of data and knowledge in the industry on how to connect them appropriately, deploy them appropriately. And there's generally just a high level of understanding of what to expect from batteries in these types of applications, from lead batteries in these applications. In terms of cost effectiveness, this is really tied to their sustainability. So lead batteries are the most recycled product in the world. According to Battery Council's international study, 99% of lead batteries are recycled. So this makes the supply chain in America and in Europe very sound for the technology. Roughly 80% of the need for lead batteries is actually brought by recycling streams. So in terms of sustainability, it's unparalleled. And this really sturdy supply chain helps drive costs down. So in terms of, dollars per kilowatt hour, lead batteries are very affordable. And then robustness. Lead batteries are used in all sorts of climates. We have case studies of them being on Mount Everest, all the way to some of the hottest regions of the world. They're used to being abused. And the battery architecture, as well as just the chemistry itself, really affords that. So in terms of things like heating and cooling and other aspects of energy storage systems, it's quite simplistic for lead batteries in terms of what is necessary. Now, all these benefits are, I would say, kind of soft benefits. We're also seeing major jumps in performance. So as opposed to 20 years ago, we're seeing much higher cycle life, roughly twice what it used to be, as well as much higher recharge capability, just to name a few.
Matt, can you tell us about any exciting energy storage projects currently underway using lead batteries?
Yeah, there's quite a few. So the lead battery industry has been working with utility companies like Ameren to launch some innovative projects, such as a EV fast charging station microgrid to help with demand response concerns related to fast charging peak power times, say like rush hour. We also have some more conventional projects underway with Ameren, looking at load response, PV shifting. We also have some work with the US military that's under development now, using lead batteries and tactical microgrids, just to name a few. That would be kind of more of a stateside development. Worldwide, there's quite a few things happening. We see lead batteries being used in microgrids, like I mentioned, in America, but also for frequency regulation, as in a 9 megawatt system that was just placed into China, as well as quite a few similar systems ranging from 5 to 8 megawatts, kind of sprinkled throughout the eastern side of China as well. We're seeing developments in Europe and Africa, especially. We're seeing the microgrid development with lead batteries being a pretty key market in terms of how quickly it's developing. So, this electrification of small communities and these medium-sized systems that are, say, 1 megawatt to 10 megawatts, that's where we're seeing a lot of development for lead batteries.
Matt, last year you launched Cbi Battery Match. Can you tell us what this is?
Yeah, that's a good question, Justin. So Cbi Battery Match is really a technical matchmaking program that Cbi has developed between prospective customers and lead battery manufacturers. And those customers could be systems integrators, utilities, government entities, just typical consumers looking to use batteries in their homes. It's really meant to be a hub of interaction. So prospective customer could see what is available, what kind of products are in the energy storage space, and get some indication of what products fit their need and what the size of their system would be. And then it would open up an avenue for them to directly engage with providers of this technology, of lead batteries specifically for energy storage. So on our side, many of our members have signed into this service, uploaded relevant battery data, and this allows for the service itself to use algorithms to help size and give some prediction about the necessary need for any prospective use. And what we've seen is, in events like ESA, it's highly useful for us to have a program like this, because it gives an avenue for prospective customers to actually go somewhere and start the conversations they need to.
Matt, thanks for joining us. Some great takeaways from your mission to promote lead batteries as a great resource for utility storage, to your goals in communicating the performance of lead batteries and carrying out research across automotive, telecom, stationary, energy storage, and motive power, as well as your forum to discuss lead battery and its advancements in the industry. Thank you again for joining us, and I look forward to speaking with you again in the future.
Thanks a lot, Justin. Thanks for your time. It's always great to attend ESA's events, and it's such a valuable resource for us and such a great opportunity. And I really appreciate everything you've done for us. You have a good day.